Hi everyone, I'm going to explain one of the most important concept of vector algebra, right? I'll do the past revision for JEE main, or you can say for state board exams or CBSE exams. These videos are very helpful at the last stage of preparation of your exam. So I'm going to explain briefly what is angle between two vectors, how to define dot product of vectors, what are the applications of dot product of vectors. Well, so angle between two vectors. So if you consider two vectors, one is a bar vector. Okay, this is a bar vector. And another one is b bar vector, b of b bar, right? That angle AOB, angle AOB equal to theta is called angle between the vectors. Angle AOB is called angle between the vectors. Angle between the vectors is denoted by ordered pair A comma B. Ordered pair A comma B. Okay, so this is the angle between the vectors. A bar and B bar vector. And this angle between two vectors is never exceeding 180 degrees. Well, here theta belongs to 0 degrees to 180 degrees. Okay. And you see that this is the minus a bar vector, minus a bar vector. Angle between minus a bar and b bar is pi minus theta. It is a pi minus theta. In this diagram, theta belongs to 0 to pi by 2. Anyway, this is an acute angle. Acute angle. All right. And angle between A bar and B bar is same as of angle between B bar and A bar. There is no sense of clockwise and anti-clockwise because angle between two vectors always lies between 0 and 180 degrees, including 0 and 180 degrees. Now this is A bar vector. So this is B bar vector. And these vectors are perpendicular. Angle between them is 90 degrees. So we write that A bar is perpendicular to B bar. Right? Or you can say they are the orthogonal vectors. Orthogonal vectors. These are the orthogonal vectors. Orthogonal vectors means they must be perpendicular. And the third diagram, right? Third diagram explains that angle between two vectors is more than 90 degrees. So this is an obtuse angle. It is an obtuse angle between the vectors. Angle between two vectors, A bar, B bar is same as of angle between B bar and A bar. If theta is the angle between A bar, B bar, then angle between minus A bar and B bar is pi minus theta. Look at the diagram. All right. So if A bar and B bar are in the same direction, okay, like in the same direction, then angle between these vectors is 0. Okay, all right. I'll write that OA, OB. O, this is, and this is B. All right. So here theta is equal to 0 degrees. There is no rotation at all. Now you see that this is assume that A bar vector and this is B bar vector. So these are the these are the unlike vectors. Unlike vectors. In this case, theta is equal to 180 degrees. Now, how do we define dot product of two vectors? Dot product of two vectors. You take A bar, B bar, two vectors, right? We define the dot product of A bar and B bar denoted by A bar dot between them and is defined as this is equal to mod A mod B magnitude of A into magnitude of B into cos theta into cos theta, where theta is the angle between the vectors. We represent it by ordered pair A bar comma B bar. And we define zero if at least one of A bar B bar is a null vector, right? Here A bar equal to 0 bar or B bar equal to 0 bar vector. So here we assume that A bar is not equal to 0 bar and B bar is not equal to 0 bar. So we define dot product of a null vector and non-null vector equal to 0. Remember, the dot product of two vectors is a scalar, it is not a vector. And that formula is mod A into mod B into cos theta. Magnitude of A bar into magnitude of B bar into cos of angle between A bar and B bar. Now I'm going to explain a few things which will help us to find out A bar dot B bar when A bar and B bar explicitly are given. Here you see that I cap dot I cap, I cap dot I cap. I cap is the unit vector along x-axis, isn't it? Now angle between I cap and I cap is 0. So therefore mod I cap into cos 0, that is equal to 1. Similarly, I can write that j cap dot j cap equal to 1 and k cap dot k cap equal to 1. Well, now I can define that I dot j equal to mod I into mod j into cos 90 degrees as they are perpendicular. This is equal to 0. And j dot k equal to 0 and k dot I is also 0. Where I, j, k are the unit vectors along x-axis, y-axis, z-axis respectively. Isn't it? Right. All right. Now I'm going to explain a few properties of this dot product of vectors. So before that, I'll write a few things that LA bar dot MB bar, we can write that LM into A bar dot B bar. And also another that A bar plus or minus B bar dot C bar we define. Of course, they satisfy A bar dot C bar plus or minus B bar dot C bar. B bar dot C bar. And what is A bar dot A bar? The most important concept is what is A bar dot A bar. So here A bar dot A bar equal to angle between A bar and A bar is 0. So I can write that mod A bar into again mod A bar according to the formula into cos 0. So this is equal to mod A square. So remember, whenever you see that mod A square, we write that A bar dot A bar. For example, if somewhere you see that modulus of A bar plus B bar whole square. So then how do we represent modulus of A bar plus B bar whole square? We write that A bar plus B bar dot A bar plus B bar. Now, I will explain a few important properties of dot product of vectors. Here I have given a multi-direction that A bar dot B bar equal to, okay? A bar dot B bar equal to. Well, this is nothing but B bar dot A bar. Okay, so dot product of vectors is commutative. Dot product of vectors is commutative. All right. And you see that the dot product of vectors A bar dot B bar is negative. Okay. All right. 1 minute. This equal to, I remove. Okay. And here I'll write equal to. And A bar dot B bar is less than 0, less than 0 if angle between the vectors is obtuse, right? If angle between A bar, B bar is obtuse, so theta is obtuse. So if angle between two vectors, they give obtuse, you take the dot product of vectors is negative as cos theta is negative. All right. Here cos theta is negative. And it is positive. It is positive if theta is acute angle. If theta is acute angle between 0 and 90 degrees. So here cos theta is positive. There are many questions based on theta. Angle between two vectors is obtuse. Angle between two vectors is acute. All right. And here you see that angle between two vectors is 0, equal to 0. All right. All right. Equal to 0. I'll write here equal to 0. If A bar and B bar are perpendicular vectors. A bar is perpendicular vectors. So remember, whenever they say that two vectors are orthogonal or perpendicular, then you have to write the dot product of the vectors equal to 0. Dot product of the vectors equal to 0. And A bar dot B bar is equal to mod A into mod B. Right? This is equal to mod A mod B for theta equal to 0 degrees. For theta equal to 0 degrees. And it is mod A minus mod A into mod B, right? This is equal to, this is minus mod A minus mod B for theta equal to 180 degrees. For theta is equal to 180 degrees, right? Unlike vectors. Here cos 0 is 1 and cos 180 degrees is minus 1. All right. So we have revised that. What is condition for acute angle? Dot product positive, obtuse angle, dot product is negative, and equal to 0 for vectors are perpendicular. And A bar dot B bar is equal to B bar dot A bar, and A bar dot B bar equal to mod A mod B if theta equal to 0, and A bar dot B bar equal to minus mod A into mod B for theta equal to 180 degrees. So now, how do we write that dot product of two vectors? Dot product of two vectors. So let A bar equal to A1i plus B1j plus C1k. B bar equal to A2i plus B2j plus C2k. Now, what is A bar dot B bar? So now we write that A bar dot B bar equal to. Okay. A bar dot B bar equal to A bar dot B bar equal to. Now you see, you take that dot with each component, each vector component. A1, A2, I dot I. A1, A2, I dot I. I dot I is 1. So we write that A1, A2. And next I dot J, 0. I dot K, 0. So like that, you can write A1, A2 plus B1, B2 plus C1, C2. So now you got that how to find out the dot product of two vectors. A1, A2 plus B1, B2 plus C1, C2. And A bar dot B bar is always less than or equal to mod A bar into mod B bar. Because cos theta is less than or equal to 1. And it is always greater than or equal to minus mod A bar. It is always greater than or equal to minus mod A bar into mod B bar because cos theta is greater than or equal to minus 1. All right. So therefore, what you can say that A bar dot B bar belongs to minus mod A bar into mod B bar comma mod A bar to mod B bar. Let A bar comma B bar is equal to theta, right? Then we know that A bar dot B bar equal to mod A mod B into cos theta. This is our basic formula of dot product of two vectors. Then how do we find out that angle between two vectors? So therefore, we write that cos theta equal to a bar dot b bar by modulus of a bar into modulus of b bar. If you want theta explicitly, further you can write that cos inverse of that expression, that a bar dot b bar by mod a bar into mod b bar. Remember how to find out the dot product of two vectors a1 a2 plus b1 b2 plus c1 c2. That is sum of product of scalar components of I, j, k. Scalar components of I, j, k. Now next point, if r bar equal to xi plus yj plus zk, what is r bar dot I? R bar dot I equal to I dot I is 1, so you will get x, and j dot I is 0, k dot I is 0. What is r bar dot j? Right? R bar dot j is equal to y, and r bar dot k equal to z. So therefore, we can write that, r bar is also can be written as r bar equal to, in place of x, I can write r bar dot I into I plus r bar dot j into j plus r bar dot k into k. All right. Okay. So remember that every time I dot I is 1, j dot j is 1, k dot k is 1, and I dot j equal to 0, j dot k equal to 0, as they are perpendicular along x, y, z axis. If alpha is the angle between r bar and I cap. R bar and I cap is nothing but angle between the vector r bar and x axis. Assume this is some alpha. And angle between r bar and y axis, that is beta. Right? Along x axis you take I cap, along y axis you take j cap, along z axis you take k cap. And assume this angle is gamma. Right? So how do we find out that angle made by the vector with the positive x-axis? Positive x-axis. R angle between r bar comma I cap is nothing but cos inverse of, we write that r bar dot I cap whole by mod r bar into mod I cap. So this is nothing but simply cos inverse of, this is x by under root sigma x square. This is the magnitude of the vector. Similarly, we can write that r bar dot j is equal to cos inverse of y by under root sigma x square. And angle between r bar vector and k cap, that is equal to cos inverse of z by under root sigma x square. Now, alpha, beta, gamma are the angle made by the vector with positive x, positive y, positive z axis. Then cos alpha, cos beta, cos gamma are known as direction cosines. Direction cosines. Okay. Which means that they will decide the direction of the vector. Who will decide? Cos alpha, cos beta, cos gamma. So that's why they are known as direction cosines. These cosines will give the particular direction of the vector OP bar. And they satisfy that cos square alpha plus cos square beta plus cos square gamma equal to 1. Cos square alpha plus cos square beta plus cos square gamma equal to 1. Here cos alpha is equal to x by root over sigma x square. Cos beta is equal to y by root over sigma x square. Cos gamma is equal to z by root over sigma x square. Adding all these, you will get that cos square alpha plus cos square beta plus cos square gamma equal to 1. Cos alpha, cos beta, cos gamma are known as direction cosines of the vector. Well, that this a bar dot b bar is always less than or equal to mod a square into mod b square is known as a Cauchy-Schwarz inequality. It is a very, very important to solve some kind of particular inequalities, right? This we got that a bar dot b bar always less than or equal to mod a bar mod b bar and squaring both sides. So which means that a1 a2 plus b1 b2 plus c1 c2 whole square less than or equal to the first vector is a1i plus b1j plus c1k, right? This and this is the a bar vector. So here I'll write that sigma a1 square into sigma a2 square. This is the square of magnitude of second vector. Now equality occurs. Means exactly we want that equality. So equality occurs when the vectors are parallel. If and only if that a bar is parallel to b bar vector. So which means that a1 by a2 is equal to b1 by b2 equal to c1 by c2. Remember, this is Cauchy-Schwarz inequality can be extended up to any finite number of quantities. Like I can take that sigma ai bi I equal to 1 to n. It is an n-dimensional space. Whole square is always less than or equal to square of magnitude of first vector, nothing but sigma ai square, and the square of magnitude of second vector, sigma bi square. Of course, I is equal to 1 to n. So this is a very good inequality to solve questions in mathematical Olympiad. Now, what is algebra of dot product of vectors, which plays a very vital role in solving of questions? All right. I'll just explain only one and rest all follows. These are similar to algebraic identities. Like a plus b whole square equal to a square plus b square plus 2ab. That is an algebraic identity. Whereas in vectors, writing two vectors side by side has no meaning at all. You have to keep something between a bar and b bar, like plus, minus, dot, cross. These four operations can be applied among two vectors. So as you know that mod a bar whole square equal to we know that a bar dot a bar. So now, how do we write that modulus of a bar plus b bar whole square? Nothing but a bar plus b bar dot a bar plus b bar. Now do the dot product term by term. You see that a dot a, this a dot a, nothing but mod a square. And b dot b, mod b square, right? And next you will get 2 into a bar dot b bar. So instead of writing directly 2ab as in the case of algebraic identities, here we write a bar dot b bar. So in the similar manner, we can write that mod a bar minus b bar whole square equal to mod a square plus mod b square minus 2a bar dot b bar. And these two results can be added and can be subtracted. And the last one is that how do we write that modulus of a bar plus b bar plus c bar whole square? What is a plus b plus c whole square? A square plus b square plus c square plus 2ab plus 2bc plus 2ac. You write this modulus of a bar plus b bar plus c bar as it is, but whenever you find two different vectors, you keep that dot product in this case. So here mod a square, mod b square, mod c square plus 2 into Here A bar dot B bar, here B bar dot C bar, here C bar dot A bar. This is a very nice, these are the very nice formulas to solve questions. For example, I can write that suppose angle between two unit vectors is theta. Angle between two vectors is theta. Then what is modulus of A cap plus B cap whole square? This is equal to A cap plus B cap whole square. Mod A cap is 1 plus mod B cap whole square is 1 plus 2 into you write A cap dot B cap. This I can write 1 plus 1 plus 2 into mod A cap into mod B cap into cos theta. So this I can write that 2 into 1 plus cos theta. This I can write that 4 cos square theta by 2. 4 cos square theta by 2. In this way, you can use the formulas very effectively using these algebraic identities of dot product of vectors. So we got that modulus of A bar plus B bar, okay, equal to, or you can say this is equal to 2 cos theta by 2. Similarly, modulus of A cap minus B cap. You can write 2 sine theta by 2. You can write 2 sine theta by 2. We can create many number of questions based on these facts. Like, for example, what is question here? Under the same consideration that A cap and B cap are the unit vectors. Okay. Maximum of that modulus of A cap plus B cap and plus modulus of A cap minus B cap is dash. This is the question. So how do we do this question? Very simple. That this expression is equal to this expression. This is nothing but 2 into cos theta by 2 plus sin theta by 2. Isn't it? The range of A cos theta plus B sin theta plus C is C minus under root A square plus B square, C plus under root A square plus B square. So it is less than or equal to 2 into root over 1 plus 1, that is root 2. So the maximum of this expression is root 2. Sorry. Here is one more important concept. What is that? A bar, B bar, C bar be 3 vectors such that sum of any 2 vectors is perpendicular to the third vector. Sum of any 2 vectors is perpendicular to third vectors. Then they are mutually perpendicular vectors. Nothing but A bar dot B bar equal to B bar dot C bar equal to C bar dot A bar equal to 0. This is very important. Sum of any 2 vectors is perpendicular is nothing but A bar plus B bar. Okay. Perpendicular to C bar is nothing but A bar plus B bar dot C bar equal to 0. So you will get that A bar dot C bar plus B bar dot C bar equal to 0. Okay, of course, proof is quite simple. Similarly, you can write the remaining that A bar dot B bar plus A bar dot C bar equal to 0. Okay. And the other combination easily you can write here B bar dot C bar plus B bar dot A bar equal to 0. So this is 1 and this is 2 and this is 3. All right. Adding 1 and 2 and 3. We get that sigma A bar dot B bar equal to 0. Okay. This is fourth equation. Now you subtract 4 minus 1. You will get that A bar dot B bar equal to 0. Remember, this is a very, very important concept. All right. Now, one more important concept is that if A bar, B bar, C bar are unit vectors and S is equal to modulus of A minus B whole square, okay, and B minus C whole square and C minus C whole square. S equal to modulus of A minus B whole square plus B minus C whole square plus C minus C whole square. Does not exceed 9. Does not exceed 9. Right? And if it is equal to exactly 9, if it is equal to exactly 9, then A plus B plus C is equal to 0 bar vector. A plus B plus C is equal to 0 bar vector. All right. So here you see that S can be expanded very easily. Modulus of A bar minus B bar whole square is nothing but mod A square plus mod B square minus 2 A bar dot B bar. Here A bar, B bar, C bar are unit vectors. So mod A bar is 1, mod B bar is 1, mod C bar 1. So the first expression mod A square plus mod B square minus 2 into A bar dot B bar. Similarly, 1 plus 1 minus 2 into B bar dot C bar plus 1 plus 1 minus 2 into A bar dot C bar. We got it. So this is nothing but 6 minus 2 times of sigma A bar dot B bar. Good. All right. Now I have to derive this inequality. Okay. Now the key point here is that modulus of A bar plus B bar plus C bar whole square is always greater than or equal to 0. Right? Here A bar, B bar, C bar are unit vectors. Expand. Mod A square plus mod B square plus mod C square plus 2 into sigma A bar dot B bar is always greater than or equal to 0. So this we got that 3 greater than or equal to minus 2 times of sigma A bar dot B bar. Now adding 6 because we want that this 6 minus 2 into sigma A bar dot B bar. So 3 plus 6 greater than or equal to that 6 minus 2 into sigma A bar dot B bar. We got it. So therefore S is less than or equal to 9. This implies S is less than or equal to 9. Does not exceed 9. So you just follow this technique to solve any kind of questions like this. Right. And this B point is very, very important. B point is very, very important. It is exactly equal to 9. Then A bar plus B bar plus C bar equal to 0 bar. Use the same technique. All right. Now, this is the last one, that geometrical interpretation of dot product of two vectors, right? Okay. So we know that A bar dot B bar is equal to mod A mod B into cos theta if theta is the angle between the vectors. So here theta is the angle between the vectors and assume that this is A of A bar and assume that this is B of B bar. And no, not here. You take exactly here. This is the B of B bar. All right. Drop the perpendicular from B on the vector A bar. Assume this is OM. Right? There are very simple terms that we use very frequently in calculus also. This OM is called, projection of OB on OA. This is known as a projection of OB on Y. This is the technical term. Projection of OB on OA. The projection of OB on the projection on the vector A bar. And here this is the projection of B bar on a vector perpendicular to A bar. On a vector perpendicular to A bar, because it is perpendicular to A bar. All right. Okay. Now you see what is cos theta from this diagram. What is cos theta from this diagram? Cos theta is equal to OM by OB, right? And therefore OM is equal to mod B cos theta. OM equal to mod B cos theta. All right. Now what is A bar dot B bar? Mod A, mod B, cos theta. But mod B into cos theta is nothing but OM. So I wrote here mod A bar into OM. Nothing but mod A into projection of B bar on a vector A bar. This is the geometrical interpretation, right? Now, how frequently we will use a projection of a vector on another vector, that is an important. This is important. All right. So from this, okay, here is A bar dot B bar is equal to A bar dot B bar is equal to, right? This is modulus of A bar into projection of B bar on A bar. B bar on A bar, right? So therefore projection of B bar on a vector A bar is equal to A bar dot B bar by mod A bar. The projection of B bar on A bar equal to A bar dot B bar by mod A bar. This is known as a vector scalar component of B bar along A bar. This is a very, very simple and very, very useful also. Very, very simple and very, very useful also. Well, so projection of B bar vector on A bar equal to A bar dot B bar by mod A bar. Now, what do you call this OM bar vector? OM bar vector. This is known as a vector component, right? OM bar is equal to, OM bar is nothing but that orthogonal projection of B bar on A bar. This is known as a orthogonal projection. So, okay, OM bar lies along A bar. So we want that is equal to OM into along A bar unit vector. So OM into A cap, that is equal to A dot B by mod A bar into A cap, that is equal to A bar dot B bar. A cap is nothing but mod A by, A bar by mod A bar. So A bar dot B bar into A bar by mod A square. Now there is another key point, that orthogonal projection of B bar vector on a vector perpendicular to A bar. On a vector perpendicular to A bar. See this one. That is nothing but MB bar. This is nothing but MB bar. So what do you call MB bar? Projection of B bar on a vector perpendicular to A bar. Not along the A bar. Not along the A bar. So that MB bar is nothing but OB bar minus OM bar. So OB bar is nothing but B bar. And OM bar, just now we have derived that A bar dot B bar into A bar by mod A square. Remember, this projection can be negative or positive, right? This projection, it can be negative or positive. It can be negative or positive. If it is positive, it lies along A bar. If it is negative, it lies opposite to A bar. It lies opposite to A bar. And if they ask that length of projection of B bar on A bar, then you can write that modulus of A bar by mod A bar. So this formulas, revision of formulas is over. In the next video, I'll explain not all, a few questions of J main on dot product of two vectors.